let's solve this problem. Design a movie rental system. I just did it, and hopefully I can explain nicely how we can do this. Basically, you're given a bunch of functions you want to implement, and so it's a company, a movie rental company, and they have a bunch of shops, like a Blockbuster kind of, and each of the individual shops, they sell movies at a particular price. And basically you just want to support the operations to search for a particular movie. What are the 5 cheapest shops? So they're all represented by IDs and integers. Then you have a rent operation. So basically rent from a particular shop, a particular movie. Can drop off a previously rented movie at a given shop. They don't clarify it here, but you cannot rent from a shop 1 and then drop it off at shop 2. You actually have to drop it off at shop 1, which makes it a lot more easier. Yeah. And then report. So return the cheapest, the 5 cheapest 5 rented movies. So out of all rented movies, which other ones are the cheapest? I guess. And you want the shop and the movie information out of that. And that's it. That's the question. Now let's look at the bounds. You have n is the number of shops. Number of entries. So the entries are given as when you initialize your system. It's the shop, movie, and price. Just 3 there. So we can try and do that. Let's think. If I just have a list of rented and unrented movies, so I could easily just find the cheapest 5 rented movies, and of course the rented movies would have to be in a list where the price comes first, so I could sort it by the price. And I have to return the shop and the movie. So this kind of information I need. So in a list, that would be good, in a list. Or maybe a set, we could put it in a set as well. And then rented, unrented, would be something like, okay, I need an easy way to access the cheapest 5 shops. I need a way to sort shops for a particular movie. So I have maybe I map a movie to maybe a set of, well, I know the prices comes first because I want the cheapest 5 shops, and then the shop comes after that. Right, so this is just going to be a set here, and this would be for rented. These are unrented copies, so maybe I'll call this one unrented, and this one rented. Right, okay, so we have 2 data structures so far. Is that all we need? Let's take a look. So first operation, cheapest 5 shops. Yep, I could just look through the unrented for a particular movie. So searching for a particular movie, and then just loop through this and return those. Return the shop IDs. Okay, that's done. So rented. What about rented? We want rent an unrented copy of a given movie from a given shop. Unrented copy of a given movie from a given shop. So I want to look through here. I know the movie, I know the shop, because that's given. But to be able to find what to remove from this list, because I want to remove it here and add it here, because I'm I'm renting something, so I definitely want it not to be in this data structure, but in this data structure. So but I don't know the price of it. I'm not given the price in this input, so I need a way to keep track of the prices. So if I had some like price data structure, and I could do maybe the shop and a movie, and map that to the price. Okay, now I have the price. I get the price easily. Once I get the price, then for a particular movie that I want to rent, I can create a little pair here and erase that from this and add the full price shop movie to this set. Alright, so that's done. And then drop off a previously rented movie of a given movie at a given shop. So to do that, I would have to do the opposite. Remove it from here and add it here, just like I would do. I'll have to find the price for that as well. And report the cheapest 5 rented movies. And we thought about this earlier, and that's just going through the first 5 of this. Alright, that's perfect. That's the data structures we need. So let's put that up here-ish. Okay, so let's now initialize our system. We have a bunch of entries, and we're going to assume that each of the movies no one has rented anything. So let's just add to the unrented this information, and also the price. So I want to keep track of, for a particular movie and shop, for a shop and movie, what's the price. So let's go through each of the entries. So E in entries. Let's make the data structures first. I forgot about that. So for the price, we could do a map of pair. We could use a pair. We could try a vector actually. A vector would work. Pair might be might be better actually. A map of pairs and map that to a price. Right, we'll call that price. And then rented. So we can use a unordered map here. And we're mapping a movie to a pair. Actually, to a set of pairs. That's the price in the shop. Call it unrented. And lastly, we also have a set of. Okay, we can install all this information in here. So we could do like a pair, and then another pair as the second of the first pair. So that might work, but let's try a vector. I think that would also work. And call this rented. We'll see. Actually, to keep it with the theme of things, I've been using a pair so far, so might as well keep it at int. I might try using a vector later. No, this is a pair, so this has to be a pair. Like that. Alright. Then, for the price, let me just say the entries are given like shop, movie, and price. So I'll name the shop and the movie. It'll be E0, that's the shop, and the movie, which is E1. And I'm mapping that to be E2, which is the price. also have unordered map and unrented, so I need to fill this up as well. Unrented. So unrented takes in a movie ID. And the movie ID is going to be E1. And I want that to be, I want to insert, because I have a set here, I want to insert a pair. That pair is going to be price and shop. So the price is E2 and the shop is E0. Cool. And that's it, I think. That should do it. Unrented, insert that for the price and the shop. Now, for search, find the cheapest 5 shops that have the unrented copy of the given movie. Then I just have to go through the unrented for this movie. So just have a vector of ints. This is the result. And then go through auto and R. This is so I'm going through the unrented movie, so let's call it M, and I'm going through the unrented list, let's say movie here, and then so this is going through a set of price and shops. I want the cheapest 5, and they're already sorted for me because it's a set. That means I just need to push back the shops, I think, because I'm returning a vector. So I just need to do result.pushback M. So I'm going through, have a bunch of pairs. Let me push back m.second because that's the shop. Now I only want to push back 5, so cheapest 5. So if that result.size is equal to 5, and break, and then return the result. All right, what do I do when I rent? When I rent, I need to remove from the unrented map one of these entries. To do that, I have to grab the price. So int the cost is equal to the price of. Now I've passed in a pair here, so it's the shop and the movie. With that information, then I can remove from the unrented. So for unrented, which movie? Dot erase. I'm assuming it exists because I think the input is valid. Now I'm erasing the price in the shop. The price I got here and the shop is given to me. So that's that. When I rent something, I remove it from the unrented and add it to the rented data structure. So that's the set. So rented, maybe to insert. First is the price, which I have. It's the cost, and then another pair here, which is the shop and the movie. Cool. And then drop, it's basically the same. So int cost, grab the cost, shop and the movie. I just do need to do the rent, but in reverse. So it'll be unrented of this movie. Instead of erase, I want to insert cost and shop. And here will be rented dot insert dot erase instead of insert. I'm inserting the costs, this shop and the movie, and the report The report returned the cheapest 5 rented movies. Cheapest 5. Well, I have a rented set, and that will be sorted. That's an ordered set, and it's ordered by the price. That's perfect. So let's just have a vector of ints. That's the result, and go through. Let's say auto const reference. I'm going through the rented movies of rented, and then say something like result dot pushback. So I need to push back. I need to push back the shop and the movie. The shop I can find as the second pairs first, and then so it'll be second first, and then r dot second. And then if the result dot size is equal to 5, so I only want to limit the result size to 5. Break, then return the result. So let's see if that works, or if there's any bug. There is a bug. So a map of pairs, and that should be like that. Okay, that seems to be working. Let's give that a go. Awesome. So this one is definitely not as fast as the previous one, which is interesting. This is my first attempt. Let's see what happens if I change this to a vector. There shouldn't be much of a difference. A vector of ints. It should still work. But this time I insert an erase from the rented. I don't actually need this extra brackets, so it's a little bit cleaner. And here I could just say r at 1 and r at 2. So that should also work. Yeah, nice. Let's see if that actually makes a big difference or not. Oh, okay. It just varies a lot, I think, because this one is pretty much identical to this solution. In fact, let's keep it with the theme of things and just do a vector here and a vector here. Everything is a vector now. Which means I can do this actually, and this all remains the same. The only thing that probably changes is if at any point I'm doing dot second, and I am. So here at m dot pushback second, let's do at 1. Yep, I think that's the only places. So let's give that a go. That seems to be also working. Now I'm just using pure vectors. Time limit exceeded. That's interesting. I wonder why. The vector events. Wow. So using a pyramid is a big difference. One other thing I could try is, I'm using a map here. I could use an unordered map, which would be faster, but unordered map does not support pairs as keys out of the box. So how might I deal with that? Well, I'll have to find a custom hash function, and let's just do a C++ search for unordered map pair hash class. Yes, I did search for this before, and I think someone gave a good answer. Let's just copy this. It's called a pair hash. This is how it's done. Just copy from Stack Overflow. And this time I need to mention how to hash. Use a pair hash. So this is overly simple apparently, but uses std hash. So this is the operator. That seems to also work, so let's submit that and see if it improves the time. Not really, no. It seems to vary a lot actually. But yeah. Thanks for watching and subscribe.